Hello everyone. Today we will be conducting the liquid crystal experiment. Essentially, this experiment takes place over two different phases. In the first phase, you guys will be synthesizing a chiral dopant, which you will be doing through an imine condensation. So you'll be starting with a secondary amine like this, where the center here that's denoted with an asterisk will either be an R or S configuration. There's going to be two different samples, and half the class is going to prepare it with one configuration, and half the class is going to prepare their sample with the other configuration. From there, you can dense this onto this aldehyde in order to give you your overall chiral dopant. You'll then be mixing this chiral dopant with a liquid crystal and see how the shearing effect of these liquid crystals is affected by looking through differently polarized lenses. Overall, in this experiment, the actual experiment itself is fairly straightforward. We'll simply be mixing the aldehyde and amine and letting them reflux for about 15 to 20 minutes. At that point, we'll cool the entire solution down in an ethanol solution in order to crystallize out our product, and we can isolate it by vacuum filtration. This crystal can then be mixed with the liquid crystals, as I said previously, to create our chiral liquid crystal compound solution. So overall, the course of this experiment, you will be finding the mass of your crystallized product. You'll be taking an NMR of your recrystallized product, and you'll be finding the melting point of your recrystallized product. This will overall allow us to characterize our chiral dopant compound before we put it into the liquid crystal setting and observe what kind of effect that it has there. Finally, you'll be looking at your chiral dopant or your chiral liquid crystal in a microscope which we have set up over there in order to see what happens under different circumstances when we look at these liquid crystals in different polarized contexts. So at this point, we've measured out the reagents that we need and we've started the reflux. In this flask, we have 0.25 grams of our given amine, whether that be the R or S stereoisomer, as well as 0.25 grams of biphenyl 4-carboxaldehyde and the ethanol in order to reflux the reaction. We'll essentially let this reflux for about 15 minutes or so and then start cooling the reaction down in order to isolate our final product. At this point, we let the reaction cool on the ice for about 15 minutes, and so we're going to filter off our product in order to isolate it. So, in order to do this, we've set up some cold ethanol in order to rinse our solution, and we have set up a butanol with a rubber connector and a piece of filter paper inside the funnel. This will allow us to isolate our crystals. So, what we're going to do is turn on the vacuum. And pour our solution over the butanol funnel. As you can see, the liquid has gone through, and there are crystals on the top of this butanol funnel. I'm going to briefly rinse these crystals with some cold ethanol in order to remove any impurities. So at this point, I'm going to let the filtrate stay on the vacuum for a couple of minutes in order to make sure that all the ethanol is off. And then we can take a melting point, prepare a sample, and make an NMR of our crystals. So at this point, we've synthesized our chiral dopant, and we've mixed a 1:1 to 13% solution of the MBBA, EBBA, and chiral dopant in these mixtures. So you can see that here we have the chiral dopant A mixed with the MBBA and EBBA, and here we have chiral dopant B mixed with MBBA and EBBA. At this point, we need to prepare our slides in order to analyze the effect of polarized light onto these samples. So in order to do that, we'll be using these little cover slides as well as these cover slips in order to prepare a sample. The simplest way to do this is to simply take your mortar and pestle and get a little bit of liquid on the bottom of the pestle part, I believe, and then simply just dabbing that onto the slide as such. We can then take one of these cover slips and carefully place it over the slide so that you get no air bubbles, or as few air bubbles as possible, and then we've prepared our sample. We will then label this as sample A and move on to sample B, where we'll do the exact same thing. Awesome. Cool. So, now that we've prepared our samples, what we need to do is analyze our samples by looking through polarized lenses in order to see how the polarized light is affected differently by each of these crystals. In order to do this, we'll be using a pair of 3D glasses, which each lens on a pair of 3D glasses has a different polarization. So if we look through the left versus the right eye on the glasses at each of these samples, we should notice a significant difference in the way that the liquid crystal looks.